Hello everyone, Mr. Fawcett back here with part 2 of our 2.7 lesson. We're talking about the relationships between f and f prime. You may notice that the title's changed. That's because I changed the title on the lesson paper. I thought it better represented what we were talking about. Today we're going to do two things. The first thing we're going to do is do the second graph problem. So we're going to go to, I believe this is page 3. Yeah, page 3. And then we're going to do one problem that deals with the function in algebraic form rather than graph form. So we kind of get two different types of problems in. Okay, so it says pictured below is the graph of f prime on the interval -3 to 4, closed interval. And we need to answer the following questions. So question number 1. What intervals or what open intervals is the graph of f of x increasing? And we need to justify our reasoning. So if we're given the graph of the derivative, what do we need to look for on the derivative graph to know where the original function is increasing? Well, when the original function is increasing, our derivative should be positive. Okay, so we need to look for where f prime is positive. Now, it does specifically say open intervals. So again, we're going to have parentheses rather than brackets. F prime is positive on the open intervals -3 to 2. And that's it, right? Because everywhere else it's either touching the x-axis or below the x-axis. So on the open interval, -3 to 2, and we do need our justification because f prime of x, and actually one easier way to do it rather than writing out these words, you can say because f prime of x, and just say greater than 0 on this interval. And you can spell that out if you want to. You can just write out the words f prime of x is greater than 0 or is positive on this interval. Either way is okay. Question number 2 says, on what open intervals is the graph of f of x decreasing? So we need to look for where the derivative is negative, because that's going to be where the original function is decreasing. So the open intervals are from -2 to 2 and from 2 to 4. Now, we can't include 2 because f prime is 0 at 2, which means it's neither increasing nor decreasing. So we do have to split those intervals up at x equals 2. So we'll have -2 to 2 union 2 to 4. Because f prime of x is less than 0 on these intervals. Okay, number 3. At what values of x does the graph of f of x have a horizontal tangent? I know I sometimes I forget to say this at the beginning, guys. Hopefully you've tried this out on your own. Again, I'm a big fan of you pausing the video and working these questions out before you watch, just so that you know where you fall and you know where your questions are and where your misconceptions are, and that you're only using the video to fill those misconceptions that you have rather than kind of give you all the answers. Because you're probably going to know a lot of these answers and relationships because we've talked about it before and you've done practice with them before. So number 3 says, at what values of x does the graph of x have a horizontal tangent? Well, if we have some place where there's a horizontal tangent, right, we could have something that looks like this. We got a horizontal tangent there. We could have something that looks like this, relative min, horizontal tangent there. And remember, we can also have something that looks like this, where there's no relative min or max, but there's still a horizontal tangent. But in all three of these cases, the horizontal tangent means that the derivative is equal to 0 because the slope of the tangent line is equal to 0. So we're just going to go back up here, look at the graph, and figure out where it equals 0. And we can see that that occurs in two spots. X equals -2 and x equals +2 because f prime of x equals 0 at these x values. All right, number 4. At what values of x does the graph of f of x have a relative minimum? Justify your answer. So if we come over here and we look at this relative minimum right here, well, let's see what's going on with the tangent line, right? We know it's 0 at the relative minimum, but right before the relative minimum, it's going to have a negative slope. And right after the relative minimum, it's going to have a positive slope. So for a relative minimum, and I just realized we're looking at a relative maximum for number 4. So I guess we're going to be answering number 5 here. Let's just make sure. Yep. So number 5 is talking about a relative minimum, so we'll be answering that right now. The derivative will go from negative to positive when we have a relative minimum. So we'll put that right here. This is actually the answer to number 5. So relative minimum at x equals, well, where does it go? Where does the derivative go from negative to positive? It goes from negative to positive nowhere, right? It never, we can see that it goes from positive to negative somewhere, but it never goes from negative to positive. So we will just say no relative minimums. Because f prime of x never goes from negative to positive. Okay, now we can come back up and answer question 4, which is just where does it have a relative maximum? Well, again, relative maximum, if we come over here to our relative maximum graph, the derivative is going to have a positive slope before it hits that horizontal tangent, and then it's going to have a negative slope directly after the horizontal tangent. So we need to look for where the derivative goes from positive to negative, and that occurs right here at x equals -2. So relative maximum at x equals -2 because f prime of x goes from positive to negative at this x value. There we go. Okay, I believe we have one more question down below. So I'm going to clear all this stuff. We're going to read it, and then we're going to come back up here, look at the graph, and answer it. We actually have 2 more questions. So number 6 says, what is the slope of the tangent line to the graph of f of x at x equals 0? So what's the slope of the tangent line at x equals 0? Well, the slope of the tangent line is equal to the value of the derivative. So all we have to do is look for the value of the derivative at x equals 0. And we can see the value of the derivative is -2. So our answer for number 6, let's make sure, let me just look at exactly how it was worded. Okay, so yep, slope of the tangent line is -2. Because f prime of 0 equals -2. Again, this is just our relationship between a derivative and the slope of the tangent line. They are the same thing. The derivative is the slope of the tangent line at a given x value. All right, let's finish off by looking at number 7. It says, what is the slope of the normal line to the graph at x equals 4? So normal line is another name for perpendicular. So the normal line to the graph at x equals 4. All right, let's go back up to our graph. So the slope of the original function at x equals 4, well, we need to look at the value of the derivative. So when x is equal to 4, the tangent line slope is equal to -2, right? So if slope of tangent line is -2, thus slope of the normal line is going to be the opposite reciprocal of that, right? So if normal means perpendicular, perpendicular means opposite reciprocal. The opposite reciprocal of -2 is going to be equal to +1/2. So we didn't have to find the actual equation of the normal line, we just had to find the slope, and that slope is going to be 1/2. Okay, let's now jump to one example of an algebraic function. And for this function, we are asked to determine the intervals on which f of x is increasing and or decreasing, and find all coordinates of the relative extrema, and you only have to give the x values. Then you're going to need to state whether they are relative minimum or maximum. Unless otherwise noted, perform your analysis on the entire domain of each function, -infinity to infinity, and provide justification for your answers. So, quick review before you pause the video and get going yourself. Find the intervals where f of x is increasing or decreasing, and then find out where f of x has a relative minimum or maximum. With all of your answers, provide some justification. Okay, so don't just put an answer, explain why the function's increasing, explain why it's decreasing, etc. Okay, so first thing we need to do is actually take the derivative. So this one should be a fairly easy power rule. F prime of x is equal to 3x squared minus 6. Now, when we're trying to find intervals of where the function's increasing or decreasing, the first thing we need to do is find out where the function has horizontal tangents, so where it's neither increasing or decreasing. If we can find out where the derivative is equal to 0, then we can look in between those zeros to know whether it's positive or negative, which will tell us whether the function's increasing or decreasing. So set the derivative equal to 0 and solve for x. So I'm just going to do that real quick. So we have two zeros. We have x is equal to plus the square root of 2 and x is equal to minus the square root of 2, or negative root 2. And this is what I'm going to do here, and you're going to use this technique quite a bit throughout the course. I'm just going to draw a little number line representation of our derivative. So this is essentially the domain of my derivative. And I know that at negative root 2, there's a 0. And positive root 2, there is a 0. Now, those are, of course, candidates for a relative minimum or a relative maximum. But before we get to that, let's first do whether the function is increasing or decreasing. Now, if these are the only zeros, then essentially, on this entire interval, from negative infinity to negative root 2, our derivative is going to be either all positive or all negative. Same thing from the interval negative root 2 to root 2, and from the interval root 2 to infinity. So to figure out whether it's positive or negative on these intervals, we need to just test one value. So let me test a value. I'll test a value 0 here. And let's be clear, 0 is not an actual 0. That's just the value I'm testing, because that is a value between negative root 2, and root 2. So let's test that. Let's do, we do this over here. F prime of 0 is equal to 0 minus 6, which is equal to negative 6. So our derivative is negative on this interval. If I want to test a number somewhere over here to the left of negative root 2, well, I could just test negative 2. So f prime of negative 2 is equal to 3 times 4, 12 minus 6, which is equal to positive 6. So on this interval, our derivative is positive. And I'll test a number over here. I'll just choose positive 2. So f prime of positive 2 also gives me 12 minus 6, which is equal to 6. So on the interval, or rather, let me get rid of this because we've already figured out what our intervals are. So f of x is increasing on negative infinity to negative root 2, union root 2 to infinity, because f prime of x is greater than 0 on these intervals. All right, so again, pause, rewind the video if you're not sure about how we came up with figuring out where f prime was positive and where it was negative. First thing we did, we found the zeros of f prime, and then we tested values on each of those intervals. So the zeros broke f prime up into 3 intervals: negative infinity to negative 2, negative root 2 to positive root 2, and positive root 2 to infinity. We can just say that this keeps going to infinity. So we just tested one x value on those intervals, which gave us the sign for all of the x values in that interval. Okay, same thing for where f of x is decreasing. F of x is decreasing on negative root 2 to root 2 because f prime of x is less than 0 on this interval. Let's try that one more time. It's a little better. Interval. Okay, so we've listed the intervals where f of x is increasing or decreasing. Now we need to figure out whether negative root 2 is a relative minimum, whether it's a relative maximum, or whether it's neither. So I'm going to get rid of some of my other work here. Oops. Just so we have some extra space. You guys should have enough on your paper, I think. I believe you had a whole page. So let's think about our ways to tell whether something's a relative minimum or a relative maximum. If we have a relative maximum, okay, our derivative goes from positive to negative. So is there any spot on our derivative number line where we go from positive to negative? Well, there is, and it's right at x equals negative root 2. So relative max at x equals negative root 2, because f prime of x goes from positive to negative. Same thing for relative minimums, except it's the opposite. If we have a relative minimum, our derivative will go from negative, our tangent line slope is negative, to positive. The slope of the tangent line will be positive on the other side. And that occurs at x equals root 2. So relative min at x equals root 2, because f prime of x goes from negative to positive. All right, so that was a lot of justifications to come up with based on what you're saying about the original function. So I encourage you to complete the rest of the problems in this packet, focusing on understanding the relationships, right? Being able to write the justifications as well as give the answers. So take some time to do that. I look forward to seeing you next time. This is Mr. Fawcett. As always, enjoy the rest of your day.